This is a video for Chapter 10, Section 3, Problem number 46, Solving a System of Three Variables Using Matrices. So here we have our system. We've got our three variables x, y, and z. We have our three equations. We're going to rewrite that in matrix form. So I've done that. And now we're looking at our first goal, which is to get this in row echelon form, meaning I want the diagonals to be 1 and all of the entries below the diagonal to be 0. So I need this entry right here, this upper left, to be a 1. It's not, it's a 3. So I look in this column to see, is there any 1s here? And there is. There's a 1 in row 3. So if I were to move row 3 up to row 1 and change these from -1 to +1, meaning negate this entire row, I would have a 1 in the upper left. So I'm going to exchange row 1 with the opposites of row 3. And there's the result. Now that I've got a 1 here, I want zeros below it. So I want that 4 to be a 0. The method of doing that is do 4 times row 1, subtract row 2, then replace it. So here I've got 4 times row 1, and I've negated all of row 2. Collecting those together, I have what I'm going to replace row 2. And there I did. I replaced row 2 with 0, -10, 7, and 11. Now I want this 3 to be a 0. So I'm going to multiply the first row times 3, subtract row 3, and then replace row 3. So here's my work. Here's the result, and I've noticed that the result is all divisible by 4, so I always want to simplify, and so I simplified it to 0, -2, 1, 1, and replaced row 3, 0, -2, 1, 1. Now I've got the first column done, 1, 0, 0. The next thing I would like is I'd like this diagonal, this next one where -10 is, I'd like that to be a 1, but that's not going to be easy. I can't combine any two rows to make that a 1. To divide everything by 10, I'd have fractions. So for the time being, I'm just going to let this sit. And I'm just going to kind of pretend that everything's okay with the diagonals. So the next order of business would be to make that -2 a 0. If my diagonals were okay, this would have to be a 0. So let's just proceed as if it were. Which means I would take row 2, multiply it by -5, and then replace that with row 3, because that would make this become a 0. You can see there I've got my work, and the result of my work is 0, 0, 2, 6. All of those are divisible by 2, so I simplify that, and I get 0, 0, 1, 3, and I replaced row 3. So everything's fine. Again, I still don't have this as a 1, but that's okay. We're going to say, let's just assume right now, we can get it there later, that we have our where our diagonal would be, and below the diagonal everything is a 0. So let's move forward for the reduced row echelon form, meaning I want that 7 to be a 0. How would I do that? Well, I would take row 2 and I would subtract 7 times row 1, because that would give me a -7 here, as you can see. And when I combine those, that position where the 7 used to be is now a 0. But if I look at this, I've got a 0, -10, 0, -10. All of those elements are divisible by -10, and I get 0, 1, 0, 1. And remember, we're going to replace row 2. So on the next page, there I've replaced row 2 with 0, 1, 0, 1. And the other two rows, row 1 and row 3, are the same as they were before. So now, if you'll notice, this -10 that used to be here that was bothering me, it's not there anymore. It has become a 1, and I have this diagonal of 1 with zeros below it. My last step here is to recognize that I can't have numbers here. I need both of these to be zeros to be in reduced row echelon form. So by taking row 1, adding it to 3 times row 2, subtracting 2 times row 3, and then replacing it into row 1, and that's what this is telling you to do. And here's my work. The result is 1, 0, 0, -2. So I need to put this in row 1, which I have. And now if we look at this, we've got a diagonal of 1, and all of the other entries in the square matrix are 0. So that means that this far right column, -2, 1, and 3, that is the solution to the system. And so I write it as an ordered triplet, and we have solved this system of three variables.